Our vision starts with Vuforia providing camera frames and TensorFlow locating the force stack during robot setup. TensorFlow is generally unreliable for complete autonomous, but it's good at identifying the force stack. Our custom software works with TensorFlow to extract the four-ring stack location and disables TensorFlow before randomization. Next, it defines a reference region on each side of the ring stack and then divides these regions into 8 slices. Each slice and region is measured using the RGB values to get the average amount of blue. A ring has a very low blue content compared to the gray mat. When it is removed, it exposes the gray mat behind one or more slices. Comparing gray reference regions to the ring regions determines how high the ring stack is. In the one ring case, only 3 of the 8 slices have large enough difference in the blue value. Because our camera sits higher than the rings, a single ring will be detected as 3 or 4 slices. Our solution utilizes the strengths of Vuforia, TensorFlow, and custom code while keeping the overall complexity low. This approach worked well, and we had 100% correct identification for all 36 matches. Come talk to us if you'd like to learn more. The ControlAward description in the game manual stresses consistent, intelligent, autonomous. We'd like to highlight our autonomous results as evidence of excellence in this area. Each starting configuration has an ideal range seen here. There's a 9-point difference between the power shots and the tower shots. Our team goal is a competition average and 90% of the ideal score. Here are our averages across the 36 matches. We not only exceeded our original goal, but we approached an average of 100% of the ideal safe score. And one more thing, the combination of 100% accurate vision, highly tuned encoder-based odometry, countless hours of testing and retesting, a custom software PID for the shooter RPM, and intentionally shooting from the side to score ring ricochet enabled us to post better than ideal scores. You can see here that our maximum scores exceeded the ideal max in every case. It's pretty clear that Inception Autonomous was an astounding success and played a large role in our point totals. There's really too many great things we learned during Autonomous to discuss here. Please come talk to us about our in-person plans during the follow-up time. While Autonomous was a large part of our score, it became apparent that teleop was just as important. In this chart, you can see how our ring scored and teleop improved over the entire season. Here are key elements of our driver controls that contributed to these improvements. The first item is our wobble control. A single button progresses through the entire range of motions necessary to pick up and drop off the wobble. Here is our driver in action with a single button and drive stick. For Meet 2, we added encoder odometry, dead wheel odometry, and an auto aim feature. Dead wheel odometry added too much complexity, and auto aim was inferior to driver aiming. We stayed with encoder odometry and driver aiming. For Meet 3, we added the equivalent of anti-lock brakes, traction control, and steering assist. Notice how smooth this manual path is. This was one of the biggest drivability improvements. Come talk to us to learn more. We also added a software PID of half a second spin up and a third a second shooter recovery, as seen here. For Meet 4, we switched to a super speed servo and added a single button rapid fire mode. Look at the before and after differences here. For Meets 5 and 6, our changes were hardware and driver practice, and thanks again for listening to our descriptions of Inception 12533 Ultimate Goal Control Systems. Don't forget to drop in during the afternoon to learn more.